Today is topic 7.3, compound events, and we are going to be learning, so our learning goal is that I can find sample spaces and probabilities of compound events. So our sample space is a set of all possible outcomes of one or more events is called a sample space. You can use tables or tree diagrams to find sample spaces of two or more events. So you randomly choose a bread and a type of sandwich. Find the sample space and how many different sandwiches are possible. So what we're wanting to do is make a tree diagram. And so first we're going to take our bread, and over here you can see we have wheat or we have sourdough. So we have wheat. Now I erase that. This is worse than my smartboard. Okay, wheat, or we have, and I'm just going to write sourdough. I'll actually write it out for you. All right, and then we have different types of sandwiches. And so we have 4 different meats that we can put on the sandwich. We have ham, turkey, steak, or chicken. And so now I'm going to make little branches for each one. So I have wheat, I can have ham, I can have turkey, I can have steak, or I can have chicken. And then with the sourdough, I can have ham, I can have turkey, I can have steak, or I can have chicken. And so the outcomes, um, I could have wheat and ham, I could have wheat and turkey, wheat with steak, wheat with chicken, sourdough with ham, sourdough with turkey, sourdough with steak, or sourdough with chicken. So I have 1, 2, 3, 4, 5, 6, 7, 8 possible outcomes. And so that would be my answer. And so the sample space is my tree diagram, and then the outcomes would be how many outcomes obviously that there are. So for each branch on my tree diagram, that gives me 1 outcome. So I just count how many branches come off of each thing. And so we're going to do the try it. And so I want you to do this one on your own and then check your answer with mine. So the try it said the sandwich shop adds a multi-grain bread option. Find the sample space and how many sandwiches are possible now. So I just did the multi-grain and then I added my branches. So there are still 4 types of meat that you could put on the sandwich. And so, and then since I ended with 8 on the top part, I just kind of continued my counting. So with multi-grain, I had 4 more options. So 8, 9, 10, 11, 12. And so I had 12 possible outcomes. All right, so the fundamental counting principle is an event, which we're going to call M, capital M, has M possible outcomes. An event, capital N, has N possible outcomes. The total number of outcomes of the event M followed by N is M times N. That seems really confusing. The only part you need to know right now, or ever, is this part right here that I just highlighted, M times N. And so I'm going to use a table first to show you the sample space, and then I'm going to use this fundamental property for method 2. So finding the possible outcomes, we just did a tree diagram above, and now you also have the option to use a table. And so what the table is, you literally draw your box, which I did for you here, and so we have the event that we are going to roll a number cube and then flip a coin. And so what you do is you write each number from the number cube, and then on the edge or on the side, we have heads or tails from a coin. So think of this kind of like a Punnett square, which I believe you guys learned about in science. So if I roll a 1, I have the option of getting heads or I have the option of getting tails. So I could roll 1 and get heads and tails. I could roll a 2 and get heads or tails, 3 heads or tails, 4 heads or tails, 5 I could flip a heads or I could flip tails, and 6 I could get heads or tails. So what this does is it gives us, not that, I wanted the highlighter. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it gives us all of our possible outcomes. So we have 12 outcomes. I tend to use the tree diagram more often than I use a table, but it's really just personal preference. You also could have done a tree diagram and had 1, 2, 3, 4, 5, and 6 written out, and then heads and tails for each one of those. So you would get the same thing no matter what. It's just personal preference. Method 2 is just using the fundamental counting principle to identify the number of possible outcomes. So when we just need to know how many outcomes there are and not a specific outcome, when we just want to know how many, all we have to do is take how many possible outcomes are on the first one. So if I'm rolling a number cube, there's 6 possible here. So there's 6 numbers on a cube, on a dice. And then on flipping a coin, there are 2 outcomes. You get heads or tails. And so all we do is take 6 times 2, and we get a 12. So this way is way easier. But like I said, sometimes it'll ask you for a specific probability of a specific event, not just how many possible there are. So if you can use the fundamental counting principle, definitely try it. So now I want you to use the fundamental counting principle for the try it. And it says find the total number of possible outcomes of spinning a spinner, so this spinner, and then randomly choosing a number 1 to 5. So check your answer here with mine once you do. You didn't have to show as much work as I did. Since I'm not physically here with you guys and we're doing distance learning, I wanted you guys to see my thought process. So there are 4 colors on the spinner. So 1, 2, 3, 4. So that means there's 4 possible outcomes to get on the spinner. And then if you randomly choose a number 1 to 5, you have 1, 2, 3, 4, or 5. And so there's 5 total outcomes there. So 4 times 5 is 20. Like I said, you could do a table or you can do a tree diagram and you'll get 20 outcomes. It'll just take a little bit of time. All right, now finding the total number of outcomes. So how many different outcomes can you make from the t-shirt, jeans, and shoes in the closet? So we're just using the fundamental counting principle to figure out how many possible outcomes there are. So if you look in our closet, we have 4 pants. We have 1, 2, 3, 4, 5, 6, 7 shirts. And we have 3 pairs of shoes. So all we're going to do is multiply all those together. So 4 times 7 times 3 is 84 outcomes. So that means in your own closet, if you only had 4 pairs of pants, 7 shoes, or 7 shirts and 3 shoes, you could wear a different outfit for 84 days. Now, you might have the same pair of shoes on for multiple days, or you might have like the same shirt with the same pants, but just different shoes. But every single day, you would have a completely different outfit than the day before just by changing one of them. So there's 84 outcomes there. How many different outcomes can you make from 4 t-shirts, 5 pairs of jeans, and 4 pairs of shoes? So do this on your own and then check your answer with mine. We have 4 times 5 times 5, and we get 100. So you have 100 different outcomes with 4 shirts, 5 jeans, and 5 pairs of shoes. That's actually kind of cool. All right, so now we're going to look at a compound event. A compound event exists of 2 or more events as As with a single event, the probability of a compound event is the quotient of the number over the favorable outcomes and the number of possible outcomes. So we are going to use the same formula as we did the other day, but adding in kind of some new top concepts that we learned today. So what is the probability of rolling a number greater than 4 and flipping tails? So numbers greater than 4 on a number cube or on a die or dice, we have greater than 4. That means we don't want to include 4. So we have 5, 6, and that's it. 5 and 6. So we have 2 possible outcomes here. And then flipping a tails. So when I flip tails, I have 1 possible outcome for flipping a tails. So I have 2 possible outcomes for my first one of rolling it on a number cube, but I have to put this over how many numbers are on the number cube. So the possible outcomes of a number cube, which are 6, there's 6 numbers on a number cube, so that's my possible outcomes. Then I'm going to multiply that times the 1 possible outcome of getting tails out of my 2 sides to my coin. So 2 times 1 is 2, 6 times 2 is 12, and then that simplifies down to 1/6. So my probability is 1/6. So I want you to try the next one on your own, and then check your answer with mine. So there are 4 numbers that would make that statement true of rolling at most a 4. So I could roll 1, 2, 3, or a 4. And there's 6 total, so that's why I put it over 6. And then there's 1 heads on a coin. And so there are 2 sides to a coin, so I put that as 1 over 2. And then I multiply those 2 events together, and I get 4 over 12, because we just multiply straight across. And then I simplified by dividing by 4 on top and bottom, and I got 1/3. So my answer to this one is 1/3. So now I'm going to have you go to Big Ideas and do your homework. Email me if you have any questions.